Okay, welcome everyone. This is just a short little side which I'm actually doing for the internal students to show them how to use some of the results they obtained in their lab experiment using a hanging column to obtain water contents and matrix potentials. So with this spreadsheet, which we did as a computer-mediated learning exercise, we use this pedo transfer function. And then in step 2, we got some Van Genuchten parameters to give us a complete Van Genuchten function, which we then use to predict the water contents at various matrix potentials, which previously we didn't have. So in the hanging column experiment, what you would have obtained, or the data that you would have obtained in your hanging column experiment would have been water contents and matrix potentials, right? So if you followed the instructions in the previous videos, you should already have a graph like this. Although I guess if you were doing the CML at Flinders, you probably wouldn't have actually done this. But all this is basically a graph of these water contents here and these water contents here against these matrix potentials. You can see those matrix potentials along the bottom, the water contents there. And you can see that the two graphs match up. So once you've run the solver, the two graphs should overlay one another quite well with the pedo transfer function and the Van Genuchten function, right? So before you actually start to play around with this, it's best to actually make a copy of it so that you don't stuff up your original. You always keep your original, and the easiest way to do that is just to click down here with the right mouse button and say move or copy, and then select the function that you want to copy, or select the sheet, the worksheet you want to copy, tick create copy, and then click OK, right? And that'll bring up a new version of it over here. See, this is our original, still exactly the same, but now we can mess around with this one as much as we want without causing any problems, right? So to keep this video a bit shorter, I've done a little bit things beforehand. So what you should have from your lab report or from your lab experiment is some matrix potentials and some water contents. And this is actually taken from one of the students' reports. Jordan, if you're watching this, this is your data. It's also the reason I'm making this video, because Jordan ran into a few problems with it. Hopefully this video will help it fix them. And so all you need to do with your actual data is you need to take your matrix potentials, right? Make sure that they're negatives, first of all. Copy them, and then paste them over here as values, right? So now you've got some extra values there, which you didn't have before, but all of these have been replaced. Take your derived water contents, copy them, and paste them here as values, right? Move this graph out the way. Again, if you don't know how to get this graph, just watch some of the previous videos and you should be fine. Alright, so now we've got some extra values here, which we don't actually have pedo transfer function values for, but that's not important, because all we're going to try and do is match our Van Genuchten water contents to these water contents and these matrix potentials over here. Right. Now, one thing I think that a lot of people will make the mistake with is that to the Van Genuchten equation here is actually targeting that theta sat over there, but this is no longer, this theta sat comes from the soils up here, and we're not interested in these because our soil isn't described here at all. So our theta sat is this value right here. So all you need to do is say copy that one and paste it there as a value, right? You'll see all these Van Genuchten parameters change immediately, and that's fine. The next step would be then to ensure that our graph is targeting all these values. So what you want to do is click on the pedo transfer graph and just drag these boxes down, right? So now you can see we've got a similar curve to what we've got over here for some of these other soils, right? Got something that's sloping down and then flattening out again over there. It's a little bit of a bump here, which is probably something worth talking about in the report. Okay, so now we've at least got our our graph from the lab results. Now we want to make sure that our Van Genuchten graph is going to match that. And this is where we end up using the solver. So first what we need to do is copy the function down, right? So just highlight this bottom cell, and then we could just nope, that's not going to work. So you're going to have to drag this one down, right? And it should populate and give you a few more values. And then click on this graph here and drag that one down as well, right? So currently that Van Genuchten graph, or that line representing the water contents for the Van Genuchten function, is nowhere near what we actually need it to be. And all you need to do now is actually run the solver, right? So if you click there, go to the data tab and then click solve, right? All of these should stay exactly the same. Just hit solve, and you can see now it's matched our values as best as it can, and it's given us some Van Genuchten parameters over here. So we'll say we'll keep that solver solution, right? That value there is nice and small. We've matched our water contents as close as we can. And what this shows you as, I guess, a useful function of a spreadsheet like this is that you don't actually need to know these parameters or these descriptions of your soil. If you do something like a hanging column experiment, it'll just give you the matrix potential and predicted water contents. Once you have these values, you can just enter them in a sheet like this and produce your own Van Genuchten function, which you can then use to get matrix potentials for values where you don't actually have a water content. So in other words, if you didn't get that particular value in your lab experiment, you can go and find it later. Okay. This bottom end isn't matching up exactly, and chances are it's because of this little drop that we're seeing over here, this flattening out and this drop. So there might have been either a miscalculation or something happened with the soil at this point. So you're seeing this little deviation in Van Genuchten function versus the actual measured lab result. So yeah, I'm not exactly sure what that could be. You could have had an air pocket or something preventing water from exiting, and then all of a sudden you get a huge chunk of water leaving, or not as much. You're dropping the matrix potential, but you're not getting as much water out. Lots of different reasons you can see things like this, but you can see along this part of the graph we're matching the trend very, very well. It's only the tail end that we're a little bit off, with maybe closer measurements or smaller changes in the matrix potential in this region. We probably would have gotten slightly better data, or something slightly better that the actual solver could match as well. Okay, so don't worry too much about this bit over here. But that's what the graph should look like. I know a few students who'd actually have this data because you're working in groups. So lucky you, I've showed you exactly what your answer sheet should look like. And in the report, I expect to see these values. Right? Don't just give me the graphs. I want to actually see these values as well. Okay, I think that's about all you need to know for how to do that. So I'll sign off.